Hi. Today we're going to take a look at the ScummVM source code. I have the ScummVM website open. ScummVM is an emulator that lets you play old adventure games. And the name is based on Maniac Mansion. I think it says it over here in the GitHub. So what is it? Script creation utility for Maniac Mansion. So Scum was Scum was created by the Maniac Mansion people, who I guess was LucasArts, for scripting their games. And ScummVM is a project that lets you play those older games, on your computer, on your PC. And it's not useful for authoring new games, according to the documentation I read a couple moments ago. But if you have like a ROM or whatever it's called when you have the data that was saved on the original game, I guess the games came in, files or CD-ROMs or discs or whatever. So if you have whatever was on those, I guess you can play the games. I don't have any of those, certainly not on this machine. So I don't know. So I can't show you what any of it looks like, but we can take a look at their screenshot. So there are a few different studios like Presto Studios, LucasArts. I've heard of LucasArts. I haven't heard of all of these. Animation Magic. And I guess this will show you what those games look like in ScummVM. Let's find LucasArts and I guess Maniac Mansion. I didn't realize there was a Beavis and Butthead adventure game. And so here's what it looks like. It looks like it did if you were to have played it back in the day on your machine. And here's Beavis and Butthead. Looks pretty good. Okay, so let's take a look at what they're up to in the source code. And let's get this thing out of the way on my other window. Whoa now. All right, there we go. Okay, so here we are. We're on their GitHub. I actually fixed the issue I was having before with IceCat. I'm still using GNU Geeks. If you take a look on my YouTube channel, there's a video where I read the source code for GNU Geeks, and I'm doing all of this lately in a GNU Geeks VM, just to sort of play around with the system. They have a version of Firefox that has a restricted set of features, trying to eliminate what they see as non-free software, but those basically broke the internet. So I disabled a bunch of that, and I'm optimistic that the web browser will work better than it has the past couple of times. And I should say, if you haven't seen any of these before, that I have a back catalog, maybe about 18, 20 videos looking at a bunch of open source projects. A lot of them are more technical projects, like the Linux kernel, the web browsers, Chromium and Firefox, and a few compilers, LLVM, GCC, the GHC Haskell compiler. And then the past day or so, I've been looking at some game-related stuff. Okay. All right, so here we are on the GitHub. We have a bunch of kind of metadata stuff in the top-level directory, which makes sense. We do have a README, which tells us about the project, which is nice. They have a wiki, tell you how to report a bug. This is good. A few of the projects that we've looked at so far don't really have a README to speak of. Poe, we saw in some other project that is most likely translation files. And in fact, if you look at the commit, it says internationalization update translation files. So that's a good guess. Audio and backends. I'm not sure what backends is, but just in the interest of, I guess today we'll try to zero in on stuff that's obviously at the core. So let's take a look at base. Engines, graphics, GUI. Math is actually kind of interesting, but yeah, I'll open it. And video. But I wonder where does, is that all we need? Let's start with that and then come back. So here's the wiki. They've got supported games. I wonder, let's see. What if I just go to the index.php? So the wiki has supported games, documentation, where to get the games, support, blah, 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 submitting demos, screenshots, and some developer stuff like coding conventions and code formatting conventions. Those are good to see. And yeah, they seem, the ScummVM people seem like they've got their stuff together from a developer viewpoint. Okay, here we are in ScummVM/base. We've got command line.cpp and command line.h. I'm guessing that that's like the Unix command line and not entering commands. But let's take a look. Register various defaults with the config manager. Parse the command line for options and a command. Okay, yeah, so this is command line parsing for starting the program up, I believe. Detection. What does detection do? Who knows? It's got a plugin object and no comment for what the file does. All right, command line internal plugins, main, we should look at, module.mk, plugins.cpp. Yeah, let's look at plugins. And then version, I'm going to assume computes and maybe prints a version number. All right, so there's not much here in this .main.h file. We're going to include common/scumsys.h. Did we have common open? No. Since it's the only thing that main.h includes, let's open up. Oh, actually, common looks like it's really important. We've got Lua. Okay, so let's get back. Let's aim to get back to common, and let's try to process through everything that's maybe less important than common. Okay, so here we are in main.cpp. You're going to import engines and meta engine, command line, common archive, config manager, events, GUI event recorder, and a bunch more common stuff. GUI manager, audio stuff, graphics. And graphics is, I guess, cursor manager, the font manager, some conversion from YUV, which I think is a color specification, to RGB, and some font stuff. So that's relatively uninteresting from a game point of view. I mean, you need to do it, but it's not doing anything super gamey. Okay, so we've got a static bool launcher dialog. There's a comment here. It says, discard any command line options. Those that affect the graphics mode and others should not blindly be passed to the first game launched from the launcher. All right, so it's a static bool. So what is it going to return? It's going to return plugin. Is plugin a bool? Oh, no, sorry, I skipped to another function. So launcher dialog is going to return dialog.runModal not equal to -1, which looks like an error condition. And we've got some if-def stuff. I don't know what __DC is. But if we have defined it, we get the DC launcher dialog. Otherwise, we get the GUI launcher chooser. And then the detect plugin is going to return a plugin. Is there only a single plugin that you can have? Let's see. Okay, so if engine ID is empty, we do a warning and return null. If game ID, so if we don't have an engine or a game, then there's nothing to do. So it says, at this point, the engine ID and game ID must be known. Okay, so assuming that we have all of that, we're going to call engineman.findPlugin on the engine ID. And if we don't get it back, there's an error. We'll say null pointer. And then we're going to query the plugin for the game descriptor. So plugin get meta engine detection. And we've got a debug manager. And anyway, we're going to find game using the game ID as a C string to the meta engine. All right, well, we don't know what a meta engine is yet. But maybe it's a engine of engines. And we've got run game, which is going to return an error condition. Let's see, what's the last thing that run game does? Is this an infinite loop? Did I miss the end? Return result, is that it? I think I've been too zealous in scrolling over. So let's go back to run. Let's see if we can just control F run game. Okay, so static common run game. And to do specify the possible return values. And the run game is going to take a plugin, an engine plugin, an operating system identifier of some sort, and a string of debug levels, which is maybe for logging. And then we're going to assert that I guess this means that they're not null, that plugin and engine plugin are not null. And we'll determine the game path by doing some file system stuff. And we're going to check if SDL backend is defined and OpenGL, etc. This is a hack. We set up the requested graphics mode setting here to allow the backend to switch from Surface SDL to OpenGL if necessary. This is needed because otherwise the G system get supported formats might return bad values. All right, so we do some set graphic stuff. We verify that the game path refers to an actual directory, and to check that it exists, we're going to add debug channels. On creation, the engine should have set up all the debug levels, so we can use the command line arguments here. Okay, so we're going to do more stuff with debug levels. You might want to. I'm wondering if some of the log stuff can be factored out of this method. That way you can, that would help you, I guess, test the method better. Like instead of passing in debug levels, maybe if I were writing this function, I might consider passing in like a logger, and then you would configure the logger before calling run game, and that would let you do things like unit test the run game function with a mock logger or whatever you have. Okay, so I think we're at the end of logging down here, and we're going to create the game's meta engine and call create instance. We'll check for errors. We're going to set the meta engine to the thing we created and set the window caption to the game name and make sure that it's not empty. Add the game path to the directory search list. We're going to engine initialize path of the directory and maybe do some extra paths. And then we're going to check if we need to use translation. I guess that's for different languages. Although, look, there's text-to-speech here, right? TTS man. If GUI use game language, so if your configuration manager has the key GUI use game language and get bool GUI game language, so I guess that means that this GUI game language not only exists, but it's set to true, and the configuration manager has a language, they will set the language to the thing in the configuration manager, and then we're going to get the text-to-speech system. What is G system? And if it's not a null pointer, we'll set the language of that to the game language. So I'm not sure if games in general use text-to-speech, but if they do, this will, I suppose, ensure that the text-to-speech language is the same as the game language. Okay, then we'll do some key map stuff here. Apply backend settings, and we'll inform backend that the engine is about to be run by calling system.engineInit. Purge any queued events on the keyboard or mouse, and run the engine run. So that's going to return an error. So I'm wondering if maybe this is the like infinite loop. Because if it returns, then we have an error, right? And I guess error might be okay. It might be no error. But the game is done running, I suppose. So make sure we do not return the launcher if this is not possible. Return to the launcher. And inform the backend that the engine finished. Yeah, okay, so when we get here, the game is done. We'll clean up game key maps, delete the engine to free up memory, and remove debug channels from the thingy. Yeah, okay. I wonder if there's a cleaner way to do the cleanup, I guess. Because what if you add a new thing, you'll have to add a new thing before the game and also a cleanup after the game. I'm wondering if there's a way to make sure that things automatically get cleaned up, like when they go out of scope. I think C++ should be able to handle that with destructors and whatnot, but maybe there's a reason that that's not done. Anyway, where did run game go? I scrolled away from it. Okay, I think this is around where I was. Then we've got, we're going to set the language to the previous language. This is more cleanup, and we're just going to return result. And 0 means no error. Okay, and we've got this. So that's the main function, right? That's kind of the entry point to the infinite loop that's going to play the game. And the real work is done by engine run. I never really thought about how to pronounce this arrow. Engine right arrow run. All right, and then we've got a setup graphics function, and system is going to call begin graphics transaction. And I guess the idea of the transaction is that we're going to set all this stuff, the graphics mode, the stretch mode, the scaler, and the shader, and that if we fail to do that properly, the transaction will just roll back. We won't have this intermediate state where we've set the stretch mode, but we're not able to set the scaler or the shader, and so things are all messed up. All right, we can get the size, and then we end graphics transaction here. We're going to apply backend settings, clear the main screen. Okay, then we can set up the key mapper, extern C int ScummVM main. All right, so I suppose this is a C routine. It's got some special debug system. It's got O system, verify that the backend has been initialized. We're going to register defaults to the config manager. Check for auto run name. And auto detect some stuff. Parse command line. Okay, register default. So some windowing stuff. I'm not sure really what this is doing or why this has to be why this is got this extern C stuff. But okay. But basically more initialization, set up the graphics. If we're on Android, does ScummVM work on Android? In this new version of ScummVM Android, significant changes were made to the file access system to allow support for modern versions of the Android operating system. Cool. If defined, use cloud and use libcurl, we're going to cloudman init and cloudman sync saves. So does ScummVM have a cloud service where you can save your game state? Potentially. Set active domain chained game. What's a chained game? However, the game may have requested that one or more other games be chained to the current one, with optional save slots to start the games at. At the time of writing, this is used for the Maniac Mansion Easter egg in the Day of the Tentacle. Okay. All right, so that's main. Here's plugins. This is a lot of defines, extern int plugin type versions. To do, make the engine API version depend on ScummVM's version because of the backlinking, possibly from the checkout revision. So we've got this register plugin static, which gets a code comment. That must mean it's important. So it's a convenience macro, which is used to declare the plugin interface for static plugins, code such as game engines, which need to implement a static plugin can simply invoke this macro with a plugin ID, plugin type, and plugin object subclass, and the correct wrapper code will be inserted. So we've got this plugin type and plugin objects, dummy function to allow trailing semicolon, all right? And register plugin dynamic. What did we have before? Register plugin static. So I guess it's the same stuff. We're going to register extern C, register plugin dynamic, DSO handle, plugin get version, get type, abstract plugin. Abstract base class for the plugin objects which handle plugins instantiation. Subclasses for this may be used for engine plugins and other types of plugins. An existing plugin object refers to an executable file loaded in memory and ready to run. The plugin, on the other hand, is just a handle to the file or object, whether it's loaded in memory or not. So we can get name. What else can a plugin do? We can load and unload. And that's really about it. How does it know what to act upon? So we can create a plugin, is plugin file name, find engine plugin, get engine from metadata, plugin manager uncached, uncached version of plugin manager, keeps only one dynamic plugin in memory at a time. Okay, so this will, I guess, unload your unused plugins. I don't have a sense of what the plugins actually do, but maybe we'll see that elsewhere. So plugins.cpp is going to be the implementation. There shouldn't be any new API here. We've got link plugin auto, music plugins. Use defines to disable or enable each MIDI driver as a static or dynamic plugin, like it's done for the engines. Okay, so these are like fluid synth I recognize as a MIDI, I guess, synthesizer or something on Linux. It compiles MIDI to sound. And then we have dynamic modules. What do we got here? We've got file systems, file plugin provider, plugin manager, add plugin provider. Okay, so what is get engine from meta engine? Or actually, that may not be the most interesting thing. Actually, yeah, let's take a quick look. So we've got let's see. It's going to take a plugin and do some asserting. It's going to set plugin engine plugin to the null pointer. and then we're going to call plugin right arrow get name, and then call plugin manager find engine plugin on that. All right, that's simple enough. Plugin manager uncached. This is kind of doing detection of plugins. Yeah, I still don't know what the plugin API is doing. What do you if you're going to implement a plugin, what can you do with it? Like what sort of functionality can you add? And then we've got more music plugins. Legacy graphics mode. Scalar manager, find scalar plugin index. So we've got scalar plugins, music plugin. Here we go. Scalar plugins, music plugins. And is that it? So let's find things that begin with a comment. Abstract plugins, plugin versioning. Anything else? Scalar plugins. Legacy graphics we saw. Update old settings. And not much else. Okay. So I'm not sure. Plugins still seem mysterious to me. Here's ScummVM engines. Blade Runner. Chamber, Chewy, Composer, Cruise. DM, Dragons, Freescape. Groovy, Grim. Let's take a look at Grim. Lure, Mac Venture. Are these all games? I think some of these might be games. Queen, Sherlock, Sky, Sludge, Star Trek Supernova, Sword 1, Testbed, Tune, Touche, Twine, Ultima, Voyeur, Wage, Wintermute, and Z-Vision. Okay. So we've got achievements.h, achievements.cpp. Let's look at dialogues. We should obviously look at the engine and the game. And I guess meta engine was used a lot. And sure, let's look at save state. Okay, so in Grim, we have Costume, EMI, iMuse, Lua, Movie, Remastered, Shaders, Update. So Lua is probably Lua scripts, and Actor CPP, Animation CPP. Let's move Grim to its own thing, and let's come back to Grim. Let's do that. All right, so engine/achievements. Okay, so what have we got in achievements? We can set active domain. I don't know what that's doing. Current language, load achievements data, and it's going to take a character pointer to platform and an app ID, and it's going to get an achievements.dat as a zip file, I suppose. And we're going to look in it for some stuff, I guess, version. And what are we doing? All right, so we've got sections list. And you're checking for prefixes. What is INI file? Is this a standard file format, or is this something that they made? I don't know. Let's look up INI file format. An INI is a configuration for computer software that consists of text-based content with a structure and syntax comprising key value pairs. Okay, so can we see this? Okay, oh, okay, so I've seen this before. So it's got this bracket thing, which is like a heading, and then in that I guess that's what a section is. And then in the section we have key value pairs. So this would probably be obsoleted by something like JSON. Okay. So we're going to read all this stuff and check for key value pairs, and that's how all the achievements are coded. And we've got ID, title, comment, hidden, stats. And I wonder if the stats are done all per game. I would suppose they have to be, right? And how does, let's see. So how does it know kind of what stats are important to save, or does it just dump the whole? It doesn't seem like for achievements, at least, it's dumping like the entire game state to a file to save the state. So it seems like it's doing something else. Okay. All right, so has key achievements, and we're just doing more files. Get stats float x. I don't know what x means, but I guess this is getting a stat as a float. Get average rate stat float, count or times. We're going to average them. We can get raw stats, reset all achievements, get achievement count. I wonder if I can find ScummVM achievements. Are these like achievements defined by the ScummVM people? Is ScummVM achievement a bad idea? So LucasArts games, blah, blah, blah. Would it be fun to have achievement? Would it be fun to have achievement in old adventure games? I don't know. Would it? Achievements in ScummVM, non-official proof of concept. I have uploaded a small video of proof of concept I did during the weekend. I don't know. Maybe this is an experimental feature of ScummVM. I don't know. Can we find out? Let's see. Let's blame. Add achievements helpers. Update Scum project license. Load achievements description. Add achievement. So 3 years ago, 3 years ago, 3 years ago. Achievement manager. Minor refactoring. Remove old API methods. Achievements. I forgot GitHub doesn't make it easy to track things like this. Okay. Whatever. I'm going to guess that this is a fairly new feature that they're building or trying out. Common achieve achievements. API related to in-game achievements. List of game achievement provider platforms. Possible candidates are Xbox, Gamerscore. Xbox, Gamerscore, PSN trophies, congregate badges, etc. So we've got Steam achievements, Galaxy achievements, and UNC achievements, which is at the -1. All right. Okay, so dialogues.h. We've got a main menu dialogue. Oh, these are like UI dialogues, not dialogues in the game. So let's not look at them. Okay, so what is an engine? An engine, it's the API for managing various functions of the engine. You can initialize graphics. You've got GUI error messages, pause token. What's a token? Class for managing pausing by engine, pause token that hands out pause tokens. Each token represents one requested level of pause. What does it mean to have multiple levels of pause? You can manually release the pause token, only allowed if the token currently represents a pause request. So is this so that like multiple things can pause at the same time and you're not, you're like reference counting how many pause requests you have? Is that what's going on? So we've got a timer manager used by the engine, an event manager, a save file manager, and a main dialog. The dialog instance. And we can run a GUI dialog. The pause level, 0 means running. A positive value indicates how often the engine has been paused. and thus how many times it must be unpaused before it resumes running. This makes it possible to nest the code that pauses the engine. Okay, yes, so that's exactly what I was wondering. I wonder if that's a standard pattern. I guess it makes sense. So it's kind of like a lock, right? So you can easily enough have a function called like ensure pause that is a null op if the game is already paused. That's like incrementing a pause level that's already above 0. But the problem with that is that you also want to ensure that it doesn't get unpaused until all of the work is done. So you have essentially an API where the inner function says, I'm done with my pause request. And the actual fate of the pausing depends on the function that called that. And the way that you get that behavior is you just have this thing that can be incremented and then functions decremented as they release their claim on the pause, I guess. That seems like a reasonable mechanism. We're going to keep track of when the pause started. I'm not sure if that's when pause became non-zero or when the last pause happened. I don't know. Okay. We'll keep track of when the engine was started. We'll keep track of autosave, the last autosave time. The save slot to load and auto-saving. Okay, what else can we do? We've got an enum of engine features. A feature in this context means an ability of the engine that can be either available or not. You can call engine has feature. So you can see if you support subtitles, if you can return to the launcher. Supports loading during runtime. Loading save states during runtime is supported. This means that the engine implements load game state and can load game state currently. If this feature is supported, then the corresponding meta engine must support the ksupports list saves feature. Okay, I am not sure what that really means, but you can also save during runtime. During runtime. I guess that's just whether like in the game, does runtime mean like as the game is running, I guess, as opposed to when the engine is running? So in the game, can you load more stuff or do you have to like quit the game to load it? I guess is maybe what that's asking. And similarly, can you save the game? Can you change the options during runtime? Can you support arbitrary resolutions? Is there a help button? And the engine provides overrides to the quit and exit to launcher dialogues. So you can override dialogue in some engines, I guess. You can create an instance of the engine. You can initialize a path. We've got some error stuff. Get or create debugger. We can check whether it has a feature. Sync sound settings. Notify the engine that the sound settings in the config manager might have changed and that it should adjust any internal volume and any other values accordingly. The default implementation sets the volume levels of all mixer sound types according to the config entries of the active domain. When overwriting, call the default implementation first, then adjust the volumes further if required. Okay. I see. So, notify the engine that the sound settings in the config manager have changed, and that should adjust any internal volume values accordingly. I guess this is just synchronizing. I was wondering at first whether it was also like normalizing, but it seems to just be synchronizing, I guess. I'm not sure. You can apply game settings. You can flip mute. I guess that's just toggling mute. It's a Z2 action on the mute variable. You can load a game state. Let's see, set game to load slot, save game state, pause engine intern, actual implementation of pause engine in subclasses. I don't know why. I would prefer this function to be called, assuming this means internal, I'd prefer it just to be called pause engine internal rather than pause engine intern. You don't get a lot saving those two letters. We return whether we should quit. This can mean either quitting ScummVM altogether or returning to the launcher. Okay. Return the meta engine detection instance. We can resume, we can pause, we can warn about unsupported games. Exist extracted CD audio files. So do we have any implementations of engines? I think we're just still in the engine class. Is that right? Okay. Chained games manager. This is a singleton class which manages chained games. A chained game is one that starts automatically, optionally loading a save game instead of returning to the launcher. Okay. We saw before that was used for like an Easter egg, I think in one of the Day of the Tentacle games. Okay, so we've got engine.cpp. That's the implementation. I don't feel like I need to look at that because I think we have a pretty good... Wait, maybe we don't. I mean, is there a real implementation to the engine? This looks like mix. So we've got some mixer stuff. Yeah, there's some real stuff that's happening, I think. There's a chained game manager. Default error handler. And actually, a lot of this looks like chained game manager. We've got some splash screen stuff. Is data and CD read from the same CD? Okay, so, I mean, there's a little bit of implementation there. So let's look at game.h. A simple structure used to map game IDs like Monkey, Sword 1, etc. to a nice human-readable and descriptive game titles like The Secret of Monkey Island. So we have these shorter identifiers, which I assume are supposed to be unique, and they map to human-readable strings. And that's what that struct does. And what else do we have? We can find plain game descriptors. Game support level, whether it's stable, testing, unstable, or a warning game. We can, let's see, MD5 hash, I guess. They're MD5 hashing files. Recording some file properties. A map of all relevant existing files while detecting. We have details about a given game. So we have a detected game, and it's going to have an engine, an ID, a description, a language, a platform, and whether it's supported. This detection entry contains enough data to add the game to the configuration manager and launch it. Okay, so they're going to keep track of whether you have enough stuff to add it to the, I guess, to the UI mainly. And we've got detection results, list recognized games, list detected games. Okay, so this is like game detection stuff. And that's game.cpp. I think we understand the from the header file enough. Okay, so now we're in meta engine.h. API for managing various functions of the meta engine. The thing that I feel like a lot of the stuff we've looked at, a lot of the projects could be improved by just having a comment, at the top, saying what the purpose of the file is. I think Golang does that. That might be, I don't remember if that's part of just the. I think that's required in Golang, right? That might be a compile time error if you don't have a code comment that tells you what's going on in that file. And you get some of that for like individual classes. I guess you need it. It's not per file in Golang. It's per module or whatever they call a Golang module. But even then, it's often nice to know like why if you have a module spread over a bunch of files, it's nice to know like what's going on in that file. Okay, so I don't know what a meta engine is yet, but we can possibly deduce it through sleuthing. We've got extra GUI objects. Okay, so per game extra GUI stuff. Some debug stuff. Extended save version is defining it before. Extended save game header. Structure describing a save game file. A meta engine factory for engine instances with the added ability of listing and detecting supported games. Every engine plugin provides a hook to get an instance of meta engine detection. Okay. For example, Scum provides Scum meta engine detection. This is then, in turn, used by the front-end code to detect games and other useful functionality. Okay, so meta engine detection is of type plugin object, and it's got get name, get engine name, get original copyright, get supported games, return some copyright information of the original engine. Oh, okay. So the meta engine, you can guess from the name meta engine that it's going to do one of two things. Either it's like an engine of engines. So it's like conceptually one level up in like a recursive engine hierarchy. And that's not what I think is going on here. I think it's a container for engines. It's a thing that manages and configures engines. For whatever, and so this copyright statement is telling me that ScummVM is not, so the original engine, I guess, is like if we have a LucasArts game, let's say Maniac Mansion has a specific engine, but if you take another game that I think is from another studio, like Beavis and Butthead, which we saw at the beginning, Beavis and Butthead would presumably be a different engine. And so I guess that's what they mean by engine. So that's the level of abstraction I think they're taking the word engine to map onto. And then meta engine is the thing that manages engines. So it could be potentially called something like engine manager. But I think they do have an engine manager that's doing something else. So there might be a name conflict if you use that name in this code base for some reason. Okay. So then we're going to return a list of games supported by this engine. And we know this because the ScummVM people are the... so another way of kind of saying, or similar to adding on to what I just said, is that the individual engines are, in some sense, not owned by ScummVM. The ScummVM people have presumably implementations of them, but the design of those engines, their APIs, etc., are not totally created from nothing by the ScummVM people. On the other hand, the meta engine is. So the meta engine is in a position to know which games they support, whereas the game engine itself wouldn't necessarily know that. Just like, the Unity game engine wouldn't know what all of the games written with the Unity game engine, right? So in that sense, it is a layer. I mean, it certainly is a layer above. You could call that meta engine. There is some logic to that. Okay, so we can find games, we can detect games, we can get MD5 bytes, custom GUI stuff, debug channels. Oh, here we go. Here's a comment. A meta engine is another factory for engine instances. Another. Okay, and it's similar to meta engine detection, and is very similar to meta engine detection. This class, however, is made of bridged functionalities that can be used to connect an actual engine with a meta engine. Every engine plugin provides a hook to get an instance of the meta engine subclass for that engine plugin. For example, Scum provides a Scum meta engine. This is then in turn used for things like instantiating engine objects, listing save files, querying save metadata, etc. Okay, and you know what? I've been reading these comments that say that Scum does this, Scum does that, and it had slipped my mind that, in my mind I was thinking ScummVM does this or that, but when they say Scum, they mean specifically the Scum engine, of which is one of many engines supported by ScummVM. So this would presumably be the Maniac Mansion engine, since that's what MM stands for. Okay, so we have the meta engine. We can get the save game thumbnail. We can find empty save slot and do some other stuff. There's not a lot it's doing. Create instances, list saves, auto save slot, maximum stuff, save state, build engine options widget. We can, basically pass some options to the engine itself. And Meta engine feature. A feature in this context, yeah, so we saw this before. A feature in this context means an ability of the engine that can be either available or not available. Okay. Cool. So that's what a meta engine is. And then we have an engine manager, which I think I said was a thing that existed, but I don't know what it does. So it's a singleton class that manages all engine plugins. So an engine is a plugin, I guess. Given a list of FS nodes, which is maybe file system nodes, we're going to detect the games within. That's detect game. We can find plugin. We can get plugins. We can get target, find games matching. This doesn't seem like it's managing engines, though. This is maybe more of an engine helper. I don't know. Okay. So then we have meta-engine.cpp. We don't need to look at that. Save state. The main thing I want to know about save state is how there's, how does a game know what state to save? So we've got save slots. We've got a save descriptor. It's got a meta engine, a slot, and some sort of ID, a string or a U32 string, a human readable description of the save state, whether you can delete it, whether there's some write protected stuff locked, date, time, playtime in milliseconds, autosave is valid. Okay. But what does it do? Determines whether the save state is write protect. Okay, that's the flag. Object describing a save state. So this is for describing a save state. So this is save state metadata is really what this is. And then the actual save state itself is possibly just managed by the game, by the original code in the game, maybe. Okay, so here we are in ScummVM/graphics. And we've got some SVG stuff, OpenGL, Scalar, TinyGL, Vector Renderer, Big 5. Yeah, I definitely want to look at Blit and Blitatari and Blitzscale, color masks, conversion, Cursor Man. Yeah, let's look at Cursor Man. Frame limiter, core font, I don't know what that is. Larry Scale generator, JavaScript and CPP. I have no idea what that is. Mode, primitives. I'm not going to really spend any time actually looking at these files. I just kind of want to know what's inside of them. That's all I want. I'll look at the vector stuff and the OpenGL stuff. Mainly because I don't know anything about vector or OpenGL code. Okay. What is even Big 5? Is this like the Big 5 manufacturers of something? So we've got a surface, ch, which is maybe a character or a channel. It's a UN16, so I guess maybe a character. Yeah, draw Big 5 car, draw Big 5 car. Chinese traditional glyph. Draw real. Is this related to Chinese support? I don't know. Okay, so Blit. Graphics blitting. You've got a transform struct that's going to convert a palette for use with cross-blit map. And we're going to pass in a UN32, I guess, destination pointer, source pointer, some colors, and a pixel format. And while colors minus minus is greater than 0, so we're going to iterate over the colors and decrement them. Destinations plus plus, we're going to increment dest. We're going to assign RB. We're going to take the color, convert it to RGB, and assign it to destination, and then increment destination. And then we're going to source plus equals 3. So we're going to move 3 in the source because we just consumed 3 source thingamajiggies. Okay, that makes sense. This blitz a triangle. So destination source, just pitch, and pitch is the width in bytes of one full line of the test buffer. Similarly for source. And this is the header file, so we don't have the implementations. And we can blit bilinear, we can key blit map, key blit. And yeah. Blitz a rectangle from one graphical format to another with a transparent color key. Okay. Blitz a rectangle from one graphical format to another. Blitz a rectangle with a transparent color key. And blitz a rectangle. So what is the blitting actually going to do? Here's blit.cpp. We're going to check if Atari is enabled. But there's also Atari blit. Anyway, copy blit. We'll check if source is equal to destination. If so, I'll return. And do this other. And we're just going to mem copy from one place to another, scaling by dist pitch times h. Wait, no, that's not scaling. That's how much they copy, right? So that's a parameter to mem copy. Otherwise, we're going to mem copy in this other way and in a loop. Okay, so key blit. Let's see. So we're going to do probably more mem copy, right? So key blit logic uint8 test source delta dest delta key. So we're calling out some other function. So we've got cross bit logic, and the main thing we're doing is, I guess, the main new thing we're doing is color to argb to color, and then this is like template programming. Okay. So I guess I'm not really sure what blitting is, but maybe Wikipedia will tell us. A bit blit. Bit block transfer is a data operation commonly used in computer graphics in which several bitmaps are combined into one using a Boolean function. The operation involves at least two bitmaps, a source or foreground, and a destination or background, and possibly a third that is often called the mask. The result may be written into a fourth bitmap, though often it replaces the destination. The pixels of each are combined bitwise according to the specified raster operation, and the result is then written to the destination. The raster operation is essentially a Boolean formula. The most obvious raster operation overwrites the destination with a source. Other raster operations may involve and, or, XOR, and not. Okay. So here's an example of blitted, masked blit operation. So we've got a sprite left and a mask right. So the sprite has this black. So the sprite is a circle, or it's shaded to look like a sphere, but it's in a rectangle. And then the mask is just masking the sphere. And the sprite is drawn in various positions over the image to produce this. Okay, so we've got the big sphere, and now we're going to blit the small sphere, I guess, into these different positions. And this is a grid because really it's rectangular, so it's being tiled by these rectangles. And I don't know what the mask is doing, but I guess the white part of the mask is saying, yeah, okay. So intuitively, what's going on, obviously, is that the white part of the mask becomes transparent when we blit it. So I'm just trying to think of like how that's achieved. So black should be like 255, 255, 255 or whatever, right? And white should be 0, 0, 0. And somehow that becomes, in whatever the code operation is, that gets translated to mean take whatever is on the background and leave that there, as opposed to writing over it. Okay. When preparing the sprite, the colors are very important. The mask, oh, this might tell us more. The mask pixels are 0, black. Oh, wait, did I have it wrong? Oh, right, okay. So white is 255, 255, 255, right? So that's, white is all, white is all color. So that makes sense. Wait, is that, I think that's the opposite of what I just claimed, but this makes much more sense. Okay, so the mask pixels are 0, wherever the corresponding sprite pixel is to be displayed, and 1, white, wherever the background needs to be preserved. The sprite must be 0, black, anywhere it is supposed to be transparent. But note that black can be used in the non-transparent regions. In the first blit, the mask is blitted onto the background using the raster operator AND. Because any value ANDed with 0 equals 0, and any value ANDed with 1 is unchanged, the black areas are created where the actual sprites will appear, while leaving the rest of the background alone. Okay, so we're going to AND operate it, and AND is going to do exactly what this says. If it's 0, it's going to remain 0, and we decided 0 is black. So anything that's black in the mask. So the mask is blitted first. So everything that was black in the mask is black here, and in fact, that's the case with this example. And anything with 1 is unchanged. So 1 is white, and the background is unchanged, which is what we wanted. In the second blit, the sprite is blitted onto the newly altered background using the raster operator of OR. Because any value ORed with 0 is unchanged, the background is unaffected, and the black areas are filled with the actual sprite image. Okay, so now, now we OR the green stuff onto it. It is also possible to use the same effect using a sprite with a white background and a white on black mask. In this case, the mask would be ORed first, and the sprite ANDed next. For some reason, I thought blitting used XOR. Some software still uses XOR to draw interactive highlight rectangles or region borders. When this is done to color images, the unusual resulting colors are easily seen. Okay, I guess you don't use XOR anymore because it does poorly with colors. So maybe XOR was a thing from back in the day of monochrome images. Okay, so that's blitting. I guess Atari is some sort of special case. Hijack service overrides here as well as these are tightly related to the blitting routine below. Function to blit a rectangle. Yeah, so this is crazier. Maybe Atari's graphic system is crazy. Function to blit a rect, version optimized for Atari Falcon with Super Vidal's Super Blitter. All right. Okay, so cursor man, I'm going to guess, manages the cursor. Show or hide the mouse cursor, pop cursor, replace cursor, support cursor palettes, etc. Okay. What is Larry scale generator? We've got some vector stuff and equality matrix, but who is Larry and what is Larry scale? It's not going to tell me? Maybe the internet will tell me. Use high quality Larry scale cell scaling. Uses special cartoon scaler for drawing character sprites. Huh. Is this a general thing or is it only on Scum? Seems only related to Scum, I guess. Was it contributed by Larry? Let's play the blame game. Who are you? Are you Larry? No, you're Daniel. I don't know who this Larry guy is. Is it related to the Leisure Suit Larry game? Who knows? Okay, mode. Mode.h. I just want to know what a mode is. We've got width and height. Okay, is that basically it? Mode with format has format, whether a pixel is valid, within pixels. Okay. Primitives. Draw a line, draw H line. So horizontal line, vertical line, thick line, filled rectangle, ellipse. That's relatively simple. It's a relatively small number of primitives. Okay, vector renderer. We've got color, struct, vector alignment, draw step. So we're going to blit source. Okay. So we're going to draw vectors maybe by blitting. Vector renderer, the core vector renderer class. It exposes the API with all the vectorial rendering functions that may be used to draw on a given surface. We can fill. We've got triangles, shadow fill, draw a line, draw a square. All right. Set gradient factor. Okay. Looks very graphicsy. But how does, okay, so step clip right, final clip. What is step? Step is a draw step. Is draw step their own thing? I don't see them importing anything. Yeah, okay, draw step. Draw step handling functions. We're going to set color. Yeah. Okay, we're going to set colors. We've got an offset. Set bevel. Set gradient factor. What is bevel going to do? That's all we get? Okay. Maybe under the hood, they're calling something that handles things like bevels. Here's shader. Oh yeah, we've got OpenGL shader. Okay, so this should be some OpenGL stuff. Vertex attrib, and it's going to be OpenGL stuff. I'm just kind of curious what code calling OpenGL looks like. Okay. Cool. OpenGL context. I think at some point I'm going to go through the OpenGL code. More context stuff. All right, GUI. We've got event recorder, metadata parser, theme engine, about, browser, chooser, debugger. I'm not going to really look at this stuff. Fluid synth, I guess for playing MIDI. Some widgets. I'm just curious how they handle theming. We've got widget stuff. Maybe they just defer to some existing graphics library, but they don't seem to import much. Let's see, where are we? A bunch of stuff in common. Graphics, managed surface, font pixel. File, okay, language. Theme engine. Dialog, background, main. So we've got different colors. Okay, so they're really just, they're defining hooks. Like, okay, so draw to back buffer. So we've got drawing routines in here. Font style. Apply screen shading. It seems like they're maybe doing all this on their own. Add font, store names. Graphics, manage surface, get image surface. Checking whether bitmap contains something. Load theme XML. Loads the default theme file, the embedded XML file found in the theme default xml.cpp, called only when no other themes are available. All right. I was kind of curious whether they were using an existing GUI toolkit, but it kind of looks like they might not be. All right, so math, I don't know what AABB is. It's going to look like group stuff. It's a vector 3D get min, get max. Oh, axis aligned bounding box. Okay. All right, cosine tables. Is DCT discrete cosine transform? Discrete cosine transforms. We've got lines, we've got matrices, modules, planes, probably quaternions. rectangles, sine windows, and vectors. Quaternion math borrowed from plib. We can make a quaternion. We can get Euler angles and do some transforms and represent it as a matrix. Okay. Fun times. Here's video. Various decoders. But they don't implement their own decoder, do they? If not defined, video/video decoder.h, MPEG decoder, get first video packet, read next packet header. This really does seem like MPEG video track. It really seems like this might actually be a decoder. At least it's it seems to be at a lower level than just calling out to like FFmpeg or something. I wonder, can I see the full history of this file? Yeah, I think if I click here, it'll take me to history, but it won't necessarily allow me to. Okay, the oldest commit is here. Add mpeg ps demuxer. I don't know. What else do we got? Blink decoder. How about Avi decoder? Avi should be something that's thoroughly supported by other software. Decoder for Avi file. Decode the next frame. It does kind of seem like maybe they're implementing their own decoder. What about the avi.cpp file? Does that import anything? Wave types, audio. It doesn't seem to import anything, any third-party stuff. And it's got this giant table. Yeah, this seems really low level. How far back does this go? It seems older than the let's see, 2011. Renamed from graphics/video/avi decoder.cpp. And renamed from some other thing. It goes back to 2009. But why? Can I see the, is that all there is to this commit? Yeah, I'm not sure why they don't just use an existing decoders. All right, so I guess we looked at, we never looked at common. I think. Let's see. Do I want to look at common? I definitely want to look at Grim. Let's take maybe a quick look at common just to spin around it. Let's see. All right, in compression encodings formats Lua, algorithm archive, array, bitstream, callback. Do they implement their own callbacks and coroutines? I have to know, so I'm going to look at those just very quickly. Error, events. I guess it would be kind of nice to know what an event is. Forbidden, we have to look at. It just seems like they're throwing down the gauntlet. What else we got? Memory. Maybe that's like, what do you call those things? Memory. What is it? Like their own implementation of free and whatnot. Recorder file, render mode, safe bool, scumsys. Maybe we'll look at scumsys. Tokenizer, translation. And let's look at some of these other directories. So Lua, Lappy. I don't know what Lappy is. L code. So this seems to be a pretty significant Lua implementations. README for Lua 5.1. See install for installation instructions. See history for a summary of changes since the last release version. What is Lua? Lua is a powerful, lightweight programming language designed for extending application. Lua is also frequently used as a general-purpose standalone language. So this seems to be, they seem to have just vendored Lua as a dependency. I don't think this doesn't have the copyright statement for Scum. So I think that they just imported Lua 5 rather than write their own Lua implementation. Yeah, okay. So coroutines, do they implement coroutines? Coroutine support for simulating multi-threading. The following implementation is loosely based on an article by Simon Tatham. However, many improvements and tweaks have been made, in particular by taking advantage of C++ features not available in C. It's kind of wild. When I started looking at the ScummVM code base, I didn't think that they were going to implement their own coroutine library. It seems like they're doing a lot of heavy lifting that there should be mature open source dependencies that they could take on. And I'm not sure whether they want to have full control over their dependencies. That's one possibility, just so that they don't have to worry about a dependency making a change that breaks them. Another possibility might be that their use case is so specific, being in this kind of emulation land, that the existing implementations don't really work for them. All right, so I guess they implement also a callback functions. Base callback is a simple base class for object-oriented callbacks. Object-oriented callbacks are callbacks that know the exact instance of the method that must be called. All right. So it's like, so the base callback, is base callback a language feature? Base callback. No, they're going to define it. Okay. All right. What's an event? Oh, yeah, this is like keyboard events. I was thinking maybe it was something more exciting. Okay. So they're going to watch for keyboard events, and they're going to do polling. Artificial event source. An artificial event source, which is made up by client-specific settings. Example use cases for this are the key mapper and the default event manager. Okay, so is mouse event. So they're going to listen for keyboard and mouse events and stuff like that. Forbidden. This header file is meant to help ensure that engines and infrastructure code do not make use of certain forbidden APIs, such as fopen, setjump, etc. And they're going to do this by redefining various symbols to a garbage string, which then triggers a compiler error. Okay. Seems like a reasonably good idea, I guess. Memory.h. So uninitialized copy. Copies data from the range it requires. Okay. This is a dangerous function, I guess. So destination, we're just going to copy over destination, and you have to make sure it's valid and uninitialized, I guess, before you copy it. And that's really all we're doing, is we're bypassing the, I guess, protections of whatever C++ is doing to initialize memory. Here's scumsys. We've got a bunch of if defs defining a bunch of stuff. In the following, we configure various targets, in particular, those which can't use our configure tool and hence don't use config.h. So we have things like little endian, big endian needs alignment, screen device. We're going to define memcopy to make an efficient inline memcopy implementation. Okay, so this is scumsys. I guess sys in the sense of like it's making sure that it's like cross-platform, essentially. What is remastered? What is commentary? Oh, I'm in Grim. All right, here's Lua. I think we looked at that. Formats, JSON, wine. or win, maybe win.exe. Encodings, that's not so interesting. Compression, these look like just various compression algorithms. zlib, gzio, stuff it. I'm not sure what it is, but it seems like it could plausibly be a compression algorithm name. Okay, so now we're in Grim. So let's take a look at Grim. I want to know what the actors are. Remastered. So maybe hotspot means they're using like the Java hotspot. We've got some commentary. Costume. Credits.pl. Detection font, graphics base, tinygl.cpp. Grim controls. Iris. I don't know what Iris is. Lab, lib, sync. So this is an engine for Grim. I'm guessing Grim means Grim Fandango. So let's look up Grim Fandango. So it's a text adventure from LucasArts for Windows. The first game by LucasArts to use 3D graphics overlaid on a pre-rendered static background. Okay, and it's got like it looks like it has a film noir. Aztec Afterlife, kind of like a Day of the Dead sort of vibe. It takes place in the land of the dead, the eighth underworld, where recently departed souls aim to make their way to the land of eternal rest, the ninth underworld. On the 4-year journey of the soul, good deeds in life are rewarded by access to better travel packages. Okay. It seems like a relatively silly game. So let's also look at Lua. Let's look at Lua graphics and Lua actor. Oops. Material. Registry, I guess we don't need. I guess I was curious about save game. Let's see if it has some game specific stuff. Sprite, text object, and text split. All right. Okay, so we're in Grim/animation. And we've got the animation is going to have a keyframe, an animation manager, and PR1 and PR2, which I'm not sure what PR means. And we've got a fade mode that's going to tell us whether we're going to fade in and fade out. Repeat mode, I guess whether the animation is repeating or looping. And there should be some sort of timer. I'm going to guess the timer is in Animation Manager maybe. And that's really all we got. We can add animation, remove animation, and animate. All right, animation.cpp. What's going on here? Update. For the first time through new time will be 0. So we're going to do some time stuff. And marker, check if it's paused. We're going to get keyframe, get marker, time, divide by 1,000 as a float. And do some other stuff. I'm not sure, let's see, what exactly 1,000 is doing. If we're checking the fade, if fade mode is non-zero basically, so we're going to, if it's fade in, the fade is going to be incremented by float time divided by float, by time divided by fade length, cast as floats. And if fade is bigger than or equal to 1 as a float, then fade is going to be equal to 1, and fade node will be none. So that's just incrementing the fade. And is it doing this at every time step? Update at time. So how often is update called? Otherwise, I think there's only one other fade mode, right? But it would be nice to have an explicit else if blah. Otherwise, we're going to, I guess, fade out, right? So we're going to basically do the opposite thing. We're going to decrement by 0. Oh, no, we're gonna check if it's 0, and if so, we're gonna set it to 0. We're gonna decrement by time over fade length, as similar to before. Okay, so if time is bigger than animation length, what do we do at the end? Then we're gonna check if it's repeated. If it's repeated, we're going to deactivate. If there's no fade mode, we're going to deactivate. Oh, okay, case once. Okay. If it's looping, we're going to set time to -1 and break. Otherwise, we might pause at the end, fade at the end. So I guess -1 must have a special meaning. I guess it's less than 0, and so we're going to, maybe the animation code checks whether something is bigger than or equal to 0. Animation save state to a save game. We're going to check, right, whether it's active, whether it's repeating, time, fade length, paused. Okay. Restore state, we're going to do the opposite. An animation manager is going to what? When we create it, for every entry, we're going to load, hang on. For active animations, we're going to create an animation pointer that points to this thing, and don't call deactivate here so we don't mess with the list we're using. What did you, and then on each of those anim things, we're going to set the manager to the null pointer. Oh, sorry, this is the destructor. Yeah, okay. we're going to clean up. All right, that makes more sense. Okay, and then when we add animation, we're basically going to do the, priority 1 and priority 2. That's what the PR referred to. Keep a list of animations sorted by priorities in descending order. Because the animations have 2 different priorities, we add the animation to the list with both priorities. I wonder what the 2 animation priorities are. And so we're going to add them to some sort of priority queue. We can remove the animation, we can animate. And model node higher, maybe like hierarchy and number of nodes. Apply animation to each hierarchy node separately. And so for each node, we're going to get the remaining weight, the current priority, the layer weight. Animations are layered so that animations with a higher priority are played regardless of the blend weights of lower priority animations. The highest priority layer gets as much weight as it wants, while the next layer gets the remaining amount, and so on. Okay. And then for common list animator entry iterator, active anims begin. So, okay. So we're going to check priority. We'll do the layer weight calculations. We're going to do something with animation time. And if k anim keyframe is node animated higher I time k tagged, we're going to increment the layer weight and then do some more stuff with priority. We're going to get the time and the weight. And then finally, we're going to call j anim keyframe animate to on hierarchy I time weight j tag. Okay. All right. So I'm not sure what all the fiddly details are, but this layer stuff is more or less reasonable. So keyframe animate. So I guess maybe the real animation is done on the keyframe, whatever the keyframe class is. Let's see. G resource loader get keyframe. So let's take a look at the header file again. I just want to see what type keyframe is. Include engines grim keyframe.h. I think I maybe opened this somewhere, but just in case I didn't. All right. Keyframe anim is a public object. It's got load binary, load text, is node animated, animate. So what does animate do? Let's look in the CPP file. Okay, animate is going to take a model node, int num float fade tagged, and without sending the bread down the tube, in Mo often crashes because it goes outside the bounds of the array of the nodes. So we're going to check the num and get the float, and if it's bigger than the num frames, we're going to set the num frames, kind of like a ceiling function, and check if it's tagged, and then we're going to call animate on the nodes. So maybe model node. So what is a model node? Maybe animation is done on the model node. Grim model. Let's look at model. Model.cpp, model.h. Okay, so we can construct a 3D model from the given data. We can reload, draw, find material, get hierarchy, geoset, load binary, blah, 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 load material, load binary, mesh face, mesh, model node, add child, remove child, draw, update, add sprite. Cool. Can we animate? Specify the animated pose. Okay. So yeah, this is pretty sophisticated. I don't have the time to really dig into how exactly this is working, but you can kind of see what they're up to. Class lip sync. All right, so we're in Grim Actor. So actors, what do they got? They've got text object, sectors, costumes, lip sync, font, set material, set shadow, joint, and EMI model. You can stop walking, is walking, walk to, set position, get talk color, which returns the color of the subtitles of the actor. So I guess different actors have different colors. You can set the subtitles. You can turns the actor toward a point in space. The effect is not immediate. The actor will slowly rotate to the destination orientation. Stop turning, set rot, which I assume is rotation, returns the role of the actor, which is the rotation on the y-axis. You can set whether they're visible, time scale, put in set. Let's see, puts the actor in a set. So I guess I saw there's another file called like set.h or set.cc, and I guess set means the same thing it does in a play. It's like a scene, maybe, or maybe it's just a collection, like a set theory set. Draw costume, stop mumble chore, stop talking, should draw shadow, collision handler, callback, update walk. What is a mumble chore? There's mumblecore, which is a subgenre of independent film characterized by naturalistic acting. But I want to search only for mumblecore. What if I just do mumble? Okay, mumble. Mumble is the official Grim VoIP software used for in-game events and member-to-member communications. Huh. Okay, so some sort of voice over IP communication stuff. All right. I don't. Yeah, let's see what. Mumble. Wait, what? Oh, I spelled it wrong. So let's see what this does. Set mumble chore. It's going to take a chore and a costume. Action chore. Yeah, I don't know. All right. Okay, hotspot. What is hotspot doing? This is in the Grim/remastered. So it maybe is some remastered release. Pool object of hotspot. I don't know. Commentary. Has heard commentary, play current commentary. Maybe the remastered version has commentary. So Grim Fandango remastered. Yeah, okay, so there's commentary. I doubt they're going to tell us what a hotspot is. Okay. Maybe it's a place that you can click on in the remastered version or something. All right. Costume. What's a costume got? Is choring. Get number of chores. Have you just looked up Grim Fandango chores? Is it like, do you have to do chores? We've got chords. Actor chores. Is actor chores a video game lingo? I don't know. Well, I guess it will have to remain a mystery for me for now. So you can fade in chores, you can stop chores, and that sort of stuff. Cool. And what else? We got costumes. I think the costume in the residual Grim E engine consists of a set of components and a set of chores. Each component represents an on-screen object, or a keyframe animation, or a sound effect. Each chore gives a set of instructions for how to move and or activate or deactivate each component at certain times. Okay, so chore is like a script. Each actor contains a stack of costumes on which a new costume can be pushed or from which an old costume can be popped at any time. For the most part, these costumes are independent. The exception is the main model component, MMDL, for which multiple costumes share the same base 3D object, if they refer to the same file. All right. And then we've got credits, and they're just going to add person to the credits. Okay, so wait. Grim.h. So maybe this is the main game engine file. We've got different engine modes. We can pause, normal, smush, or draw. Speech mode, text only, voice only, text and voice. Okay, these are, I guess this is like implementing all of this stuff for all of the engine API stuff for the Grim Fandango thing. We've got some joystick stuff. Blah, blah, blah. Flip, enable, short frame, build, active actors list. We've got Grim controls, which are various key codes. Handle controls, handle joy axis. Cool. Iris. I just am curious what Iris is. Iris can play, draw, update, save state, or restore state. I don't know. We've got class save game. Yeah, I don't know what this is doing. Lua. I'm not sure. So we've got Lua opcodes. A list of arguments to be passed to a Lua function. Lua base classes, I guess. And some get bool, push bool, ref system table, ref text object with. I don't really know what all that is doing. I don't know Lua, so I'm not sure what it's doing. So we can Lua push function, Lua opcode. So this is manipulating opcodes, I guess. Register Lua, register the Lua system table. Force demo, register opcodes, set frame time, do file. You're going to pass it in a file name. You're going to open it, and you're going to do buffer. So you're going to read it to a buffer and then do everything that's in the buffer. We've got Lua callbacks. You can get font, get color. You can parse message text, and a bunch of stuff. All right, here's Lua graphics. You can get images, free images, clean buffer, start movie, is movie, stop movie, draw polygon. So I guess the idea of Lua in a video game context is it makes it easier to do one thing after another, like a script, without all of the C++ rigmarole. But ultimately, so it's building. It's got these opcodes, I guess, and it's got some sort of virtual machine that's being handled and is ultimately doing game stuff. I guess I've never programmed a game, but that's kind of what that was kind of my impression going in. That seems consistent with what I'm seeing. All right, we've got Lua actors, and it's going to presumably do actor stuff. Get camera actor, set tall color, set chore. All right, MD5 check dialog. I don't think I need to look at MD5 stuff. Material. And that's like stuff like textures. Material.cpp. PNG surface get pixels. Init grim. All right, so it's loading stuff, texture files. Okay. Now what is save game doing? We've got save game major version, write minor version. We can write a vector 3D. We can write string, write byte, write float. Do I have the save game.cpp? Okay, let's look at the CPP implementation. Save game header tag. Open for loading. Okay, open for saving. We're going to save the header tag, the major version, and the minor version. And a footer tag. And what is this one? Begin section. Try to begin a new save game section without ending an old section. So I guess it's an error. When we read, we're going to just mem copy stuff. Yeah, so we're just literally going to mem copy stuff. So I guess we are just like saving the memory contents. Is that right? We can read byte, we can read bool, we can write. And when we write, we're going to mem copy. Yeah, okay. So I'm not sure exactly what's going on, but my mental model will be that save games, at least for the Grim thing, or there's going to be some structure to the file, but ultimately we're just dumping what's in memory into the save game. And that has to work, presumably that has to work cross-platform. I don't know if that's obvious that should work or not. Okay, so what is a sprite? Or an engine/grim/sprite. So a sprite is going to have a blend additive, which might be similar to opacity, maybe. Depth test, alpha test. It's going to, I guess, tell you how blendy it should be. We've got vector position, width, height, whether it's visible, what material. And it's got sprite next. So it's kind of like a linked list sort of thing. Okay, so one sprite can point to the next sprite, and that can point to the next sprite. And we draw. So let's see what next is called. Okay. And we can set the next to null pointer. I don't know. It doesn't seem like next is really called. Load grim. Scan F in this format. I'm going to load resources. Get the width, height, and position by computing. Then set the default flags for Grim sprites. And then load binary. We're going to get the name length from some stuff. We're going to seek, I guess, 40 characters or 40 bytes or something. Okay. Text split. A utility class to help in parsing the text format files. Splits the text data into lines, skipping comments, trailing whitespace, and empty lines. Also folds everything to lowercase. All right, cool. We don't need to look at text split then. A text object, is this more text file stuff? Text object comment. Oh, this is maybe for setting text onto the screen because we've got X, Y, font, duration. Maybe for... what's the word, like subtitles? And then here's set. So what is a set? It's got light and shadow. We can load text, load binary, set up camera. Yeah, this seems to be, a set seems to be like a play set, like if you go to the theater. Find closest sector, find sector, sort order, unshrink boxes, get rotation set up, get shadow count, etc. Light, load binary, save state, set shadow. Huh, okay. Well, that's the end of the browser, the many browser windows that I opened. So that's ScummVM, and it's pretty complicated. They do a lot of stuff that I did not really expect them to be doing going in, like implement their own coroutines, and what else did they do that I was surprised by? Call their own callback functions, their own AVI encoder or decoder. I forget which they were doing. And then, of course, for each engine, they need to have an implementation of the engine that needs to be reverse engineered. So there's a lot going on. It's a pretty complicated project. And so, yeah, that was fun. And that's all for me for now. Thanks.